Concrete production has a big carbon footprint, but recycling it makes a big difference. Erica Celeste reports.
Concrete is the most widely used building material on Earth. While it makes modern life possible, Notre Dame professor Yaya Kuruma says it also has a huge carbon footprint.
It is very intensive in terms of its demands on energy, on water, on land space, everything.
To reduce those harms, the industry has concentrated on things like reducing concrete and concrete byproducts. While recycled concrete is already used in sidewalks and roads, Kuruma and his team, along with scientists from the University of Texas Tyler and New Mexico State University, are trying to determine if it's strong and durable enough to construct buildings.
Currently, there's a lot more supply of recycled concrete aggregates than demand. What we're trying to do is bring up the demand and at the same time generate the engineering background that these materials can be used in a higher level application.
Kuruma's team is studying different recycled aggregate combinations in hopes of supplying that demand. Graduate student Michael Brandis says they're interested in two sources of recycled concrete.
The traditional RCA, or recycled concrete as we call it, is something that comes from a bridge that was demolished, a building that was demolished, and basically what that means is it has the opportunity to accumulate a lot of other materials, but we don't want to have to sort that out, as that's an added cost in using the material.
The other source is rejected material from a precast plant, which has no construction debris mixed in. The team is testing both types of recycled cement to determine durability and life cycle costs, as well as how they might engineer around any differences between the recycled materials and traditional cement. Currently, without that research, federal building codes bar its use in constructing buildings. Kuruma says that recycled cement reduces concrete's environmental impact by about half, and in some instances, recycled concrete is proving even stronger than its natural counterpart.
Nobody is going to see an immediate effect of this, but if you think about the impact of our built infrastructure 20 years, 30 years, 40 years, 50 years down the road, this will make a big impact in terms of reducing that impact of concrete on our environment.
And that's good news, because it's expected the world will need about 4.4 billion metric tons of concrete a year by the year 2050.